Hi all, my name is Willis and my presentation topic is Wireless Penetration Tool. These are today's agenda. To begin with, I will share a little bit about the company's background. Then I will walk through with you all about the project overview, including motivations, objective, and the challenges I face. Aside, I'll be showing some outcomes and business value of my project. Before finishing my presentation, I will share my contribution and key learnings that I have acquired throughout the journeys. Company overview. Keysight is an American company that manufactures electronic test measurement equipment and software. If you ask me to summarize Keysight in one word, that would be measurement. Keysight main business focuses on developing measurement tools such as oscilloscope, signal generators, logic analyzers, and etc. Keysight collaborate with business partners from different industries such as communication, automotive, aerospace, to make sure their product is measured to be safe and secure for user to use. Project overview. Before I move into the main topic, I would like to go through different wireless technology that is currently available, and I'll explain which are the best wireless technology for IoT product. There are dozens of wireless technology. The familiar ones are Wi-Fi, Bluetooth Classic, Bluetooth Low Energy or Bluetooth Smart, infrared, cellular connectivity like 2G, 3G, 4G, or 5G, and near field communication, also known as NFC. However, not all wireless technology are suitable for IoT product. In our definition, an ideal IoT product should be usable by consumer out of the box, require minimal setup, and bidirectional. Infrared only support one direction. Cellular connectivity like 2G, 3G, or 5G requires many base stations. NFC only connects at a minimal distance, which is less than 20 cm. So in our definition, the best technology for IoT product are Bluetooth and Wi-Fi. Our motivation is to help create a secure and safe environment to use IoT product. Smartwatch or Fitbit have received tremendous attention lately. What if the connection between your phone and Fitbit is insecure? Hacker might be able to retrieve some sensitive information from it. Also imagine what would happen to a patient when their automated drug inhaler got crashed while using it. The worst case scenario will cause this patient to be sent to ICU. Door lock, the tool that safeguard your house from stranger. Imagine if the door lock got crashed. The worst case scenario is not about a thief stealing your treasure, but if there's a fire accident and you couldn't escape from the house. So our motivation is simple, is to prevent this from happening by finding out the problem before it is released to the public. The objective of the project is to develop a software that is capable of automatically scanning BLE products for vulnerabilities ranging from system on chip to large and complex automotive. Aside from that, we also code and document vulnerabilities and non-compliances. Lastly, we also try to discover new vulnerabilities and preempt the manufacturers so that they could patch the bug. Challenges. One of the biggest challenges I face when developing an exploit is checking packets information. To give you an example, we know that smartphones or smartwatch talk to each other by sending data. From the documentation, we know the size of the data that allows to be sent to each other. In this case, if you look at protocol data unit, it allows data size from 2 to 257 bytes. What if you change the byte size to 259? Besides, we also ask questions like, what if we change the value to something else? Once we have set the value that is different, we observe the response. However, sometimes target device will respond differently. For example, when we send a malicious request and expecting response A, there are a few scenarios that might be happening. First of all, the target device might respond with response C, and the device still working normally. So the question is this a vulnerability? Second is, the target device will respond with response A, the correct one. However, the device crash. Then we ask again, is this functioning correctly? In other case, device might crash completely as well. These scenarios can happen often due to manufacturers not following Bluetooth standard. There are hundreds of devices out there, and we have tested a number of them. Different manufacturers seem to have different standards. This has significantly increased the difficulty in determining the response output. To resolve this issue, I have proposed a solution by adding a filter algorithm to the responses. This filter can check the responses and categorize the responses into 4 different groups, which is vulnerable device, non-compliant device, secure device, or the device does not configure properly. Outcome. This is the timeline of the project development. It is also a summary of how the project is scheduled. We start from scratch by selecting framework and take into consideration of open source license and proprietary licenses. Slowly, we move on to wireframe design, service layering of the entire software. Then we list out user stories and function. One of the key functions that we have included in the software is that it is capable of automatically scanning device for vulnerabilities and show a simple feedback to the user. These are the simple steps to perform a scanning. First, prepare a Fitbit or any other BLE device. Turn on the software, start scanning it. The software will report 4 different outcomes to inform the user whether the device is vulnerable or safe. On the next slide, we will do a simple video demonstration on a real Fitbit. You can see that the Fitbit is working, and then we start testing it with scripts. The Fitbit crashed and stopped functioning. This is a simple testing, and we have shown that Fitbit is able to crash completely with a simple scripts. The business value of the project. The business value of this project is that it is capable of scanning devices of different in size, from automobile to healthcare device like Fitbit, and to lowest level system on chip. This helped the company to partner with businesses from different industry so that this industry product can have a safer and more secure communication using Bluetooth technology. Contribution and key learnings. This is a summary of my accomplishment and key learnings throughout my internship. We managed to develop a software to automatically penetrate BLE devices. This is critical for BLE device manufacturers to deliver a safe and secure device. To enrich the software even further, we have also documented and coded 16 vulnerabilities and 13 non-compliances in the software library. This has also widened the testing interfaces. Working in this project have deepened my understanding on BLE architecture, enhanced my various Python skills and C skills. Also, with the weekly stand-up meeting, I've managed to grasp better understanding on agile and presentation skill. Before I end my presentation, I would like to thank my supervisors and all the lecturers in NUS ISS team for guiding me in this wonderful journey. Thank you.